This conference will now be recorded. This conference will now be recorded.
Okay, right. So basically, why we are going to use the SSH mechanism, right? So if I take an example here, I have two servers. So this is my server 1 and this is my server 2, right? So now here I would like to connect from server 1 to server 2, or suppose this is my workstation, my laptop. Now here my application is running on the server 2. Something went wrong. Application is down. So how, like, what is the next step here? So the next step will be you are trying to connect to the server wherever the application is running. Then you will see whether the application is up or not. The first troubleshoot. So now if the application is running on the server side, then the issue will be your browser. Your browser here is having some issue, right? That is a different story. So now the thing is, the first troubleshoot or first thing what we are going to do here is we are trying to connect to the server and we'll see what's happening inside the server. So now here it is a single server, but in a real time in the projects we are going to maintain huge amount of servers, like 100 servers, 1000 servers. So now you are not going to go individually to the server and connect the server and see what's happening inside the server, right? You cannot means you are not going to do like that. It's a time waste process. So now what you will do, whatever the servers we are having here, like the number of servers, you are going to connect from your workstation only. So if I consider this is a workstation, so I'm going to connect from my workstation whatever the server I need, like this, right? So now if you want to connect the other servers, like one server has to communicate the other server, there we are going to use the authentication mechanism, right? So now the authentication mechanism, if I take, there are two ways: username and password, and the second one is SSH. Right. If you want to communicate, if you want to connect any server from one server to another server, or from your workstation to the other machine, there either with the username and password or the SSH mechanism. So now username and password is not the suggestible one. Like there is a chance of hacking and other things. So SSH is the most secure way to connect the other servers. When you are going to deal with the production servers, nowhere we are going to use username and passwords. There always will be the SSH mechanism. Right. So now SSH is nothing but secure shell, connecting the server with the secure mode. Right. So how the SSH mechanism is going to work here? So now if I take the username and password, simple, on the server you will be having a user. Suppose I would like to connect this server. So now here I will be having a user like Shankar. Then he will be having some password. So now simply what I will do, from my server I'm going to enable the SSH mechanism there, SSH port 22. Then I will use username Shankar and the password so that I can connect directly. That's what the SSH username and password. So now if I take the SSH mechanism, there we are not going to use any passwords. We are going to use the keys. The keys are nothing but here we are going to generate a key called private key and one more key called public key. So now here the SSH mechanism will work with the keys. The keys are nothing but the private key and the public key. So now here the who's like the keys belongs to the person, who is the person the key is having, right? So now for that, now first you are going to create a user. For the user you are going to create the private key and public key, right? So now here what I will do, first I am going to create a user here like Shankar. Then for the user Shankar, instead of taking the password, I am going to take the SSH keys. The keys are nothing but the private key and public key, where we are going to create. So now these keys we are going to create from which server you want to connect. So I would like to connect from a workstation. So right, so from here I want to connect all the servers. So I am going to create a user on my workstation and for the user I'm going to create the private key and public key. So the source, on the source we are going to create the private key and public key. So now here the user is ready and private key and public keys are ready. So I will show you how to create the keys. Now I would like to connect from my workstation to the server one. So now what I will do, so to connect with the SSH mechanism, whatever the key I have generated here on the workstation, the key I am going to copy into the other server which I want to connect. So this is the server I would like to connect. So on this mission, I am going to copy my public key. We are not going to share the private key to anyone. If I share my key means I am going to give my access to other person. So never ever we are going to share our private keys. So now whatever the mission you want to connect from your source, nothing but your workstation, the destination mission, on the destination mission or on the destination server, we need to copy the public key, whatever the key we have generated for the user. So again here we are going to have a user same Shankar, and now the public key I'm going to copy. So the same thing we are going to do, the same process we are going to do on all the servers. Now the user and the key. So now here, when I want to connect from my workstation, so I'm going to use the user called Shankar. Now it's going to fetch for the user Shankar here. Yes, both are in sync, means the user got found. Then it is going to try to communicate the private key with the public key. So now this private key will try to communicate with the public key. So now if both are matched, then the communication will be established between the servers. If the keys are not matched, then it is going to reject you. It is going to deny you. Right. So now here the process will be, we require a user. The user has to have a private key and public key on the source side, and on the destination side the same user has to be exit. Then like for the user we are going to copy the public key only. Then we are going to use the SSH mechanism to connect the servers. Simple steps: create a user, create private key and public key, and copy the public key on the servers and connect it. Right. So now here let's see with the use case, like use case in the sense with the example. Right. So I'm going to create two missions to see that the communication between the servers with the SSH. So then I will create a user on both the missions. Then I will create the private key and public key on the source, and I will copy the public key onto the destination. Then we'll try to connect the server. Right. So these are the steps. Right. Let's go and see. So in our real time, usually like there are ways, the different ways you are going to follow to connect the servers. Usually we are not going to create n number of users to connect your production servers like Shankar or Teja or some XYZ or Rakesh or Rajesh, not like that. So here we are going to have a common user. Now the common user we are going to use to connect the servers. Instead of creating n number of keys, we are going to have a common user. Now the admins will be having the private key of that common user, like DevOps. DevOps is the user I'm going to use. Whatever the private key I have generated for the DevOps user, the key I'm going to share to the admins, to the DevOps folks. Then the public key will be copied into all the servers. So now whoever wants to connect the server, they are going to use the DevOps private key with the DevOps user, and they are going to connect it. Easy maintenance. Instead of creating for each user a separate private key and public key and copy all the public keys into the servers. Right. Yes, it's a practice, a best practice you are going to follow, but it's not like it's a mandatory. Up to the project and up to the architecture. If they want to have a single key or if they want to have a separate keys for each user, that is up to the project level. But in the background, the process remains same. Creating a keys, copy the public key, and connect it. Right. So let's go and see how to use this SSH mechanism. So now here, okay. So I'm going to launch an instance here. review and launch. I am taking the Ohio key, select launch. So I'm going to give the name as a server 1. One more machine I'm going to launch. Review and launch. I'm going to give the name as server 2. So now I have launched 2 servers, server 1 and server 2. Now let me connect to the server 1. Copy. Already I'm in the downloads directory, so I'm going to connect directly as. Right, so now right now by default it is going to log in with the EC2 user. That is the default for the AWS. Now I'm going to switch to admin sudo -i. So now I am in the server 1. I'm going to connect to server 2 also. Select, connect, copy. Switching to the admin. Done. So now here I have 2 servers, 1 and 2. You can observe 174 here and 63 here. 2 different IPs. Now I want to connect from this server to the other server via SSH mechanism. Right. As discussed, the first thing is we require the user on both the servers, and on the source, whatever the user we are having, for the user we require to create a private key and public key. Right. So now I am going to create a user here. So on our Linux machines, if you want to see the users information, right, I would like to see whoever, like what are all the users are there. I want to see the users list. So to see the users information, there is a file called passwd. I think we have covered it, but I'm repeating it again. So passwd is the file. There you can find all the users information of this particular server. Right. So now this file will be located in a directory called etc. So in the etc directory, you are going to find this file called passwd, so that you can know the users information of this particular server. So I'm going to open this file, cat. Now this is all the users information. ect-user is the default one whenever you are trying to log in. Now I'm going to create a user called Shankar. So now to create a user here, user add is the command, right? Then username Shankar. Enter. Right. Now for the user called Shankar, I want to set up the password also. To set up a password for a user, passwd is the command. Passwd is here the file. If I give passwd is the Linux command to set up password for a particular user. So now passwd space, for whom you want to set up the password. I want to set up the password for the user called Shankar. Enter. It is going to ask you the password. Here I am going to give the same username as the password, Shankar and Shankar. Now I created a user and I have set up the password for the user. Just confirm it, cat etc passwd. Now I can see a entry for the user called Shankar is created in the passwd file. Confirmation, yes, the user is created. Right. So now here, this is the source. I am going to consider this machine as source machine or my working station. Now from this machine, I want to connect the other machine with the help of SSH. Right. So now the first step will be create a user. Now the user creation is done. The second step will be create private key and public key for the user. Right. So now to create the private key and public key for the user, first you need to switch to that user. Right. So right now I am with the root. I log in as a root. Who am I is the command. It is going to tell you who is the user logged in. Root. Right. So now the step will be, if you whenever you want to create a private key and a public key for a user, you have to switch to that user. Right. I'm going to switch. Su is the command to switch the user. Correct. Su. Then followed by the username Shankar. Right. So now here the extension, it is going to follow the previous user. So now to remove it, simply give the cd and enter, so that you will be with the your user home directory. So now here I switched from the root to Shankar. So now I would like to create the private key and public key for this user. So now to create a private key and public key for the user, the command will be ssh -keygen. ssh-keygen is the command to create private key and public key for a user. Enter. So now when I hit the enter, it is going to tell you enter a file in which to save the key. A file name it is going to ask you, right? So if you want to give some file names, so like Shankar private key, you can give the file name. Otherwise, you can leave as it is, so that the system will create a file for you with the name called id_rsa. This is the file name which the system is going to create if you don't mention any file name. Where it is going to create? Under the home directory of the user. This is the home directory of a user, home location. Under the home directory of a user, it is going to create a hidden directory called SSH. The system will create automatically. We don't need to create anything here. So under that hidden directory, it is going to create a file called id_rsa. That is nothing but the private key. So now I'm not going to give any name. I will follow with the system given file name called id_rsa. Enter. Now you can see hidden directory is created. It is going to tell you created a hidden directory called .ssh. Now here there is one more entry called enter passphrase. Second level of authentication. Right? If you want to have two layers of authentication, one is with the SSH, and again on top of the SSH, you want to apply the password also. Two layers of authentication, more secure. Then you can give a passphrase here, like a password, so that with the SSH, and again you are going to follow the password to connect the servers. So now I don't need any password. I don't require any password, since SSH is enough for me. Then simply leave it as it is. Enter. Enter. Done. So now I did not enter anything here. Simply I left for the system only. It has taken everything. Simply I have hidden the enter key twice or thrice. Then here you can see your identification has been saved in .ssh with the name, with the file name called id_rsa, and your public key. So this is nothing but the private key, and your public key has been saved in the same location, with the name called id_rsa.pub. Pub is nothing but the public key, the extension. Let's go and verify here. So now, as the system is saying, it created a directory called .ssh, hidden directory. So let's verify here. ls, obviously you are not going to see because it is a hidden directory. So ls-a .ssh I can find here. So now let's go to the .ssh ls. Now I can see there are two files, id_rsa and .pub. Open the first one, cat id_rsa. Enter. Now we can see, as I am saying here, it is a private key. when I open the file, you can find the information here. Private key starts and ends. So this is the complete private key, 2048 characters format. That's why more secure we cannot hack this key actually, right? So to format, the key will be there, the private key. Then public key. For this private key, this is the public key, the SSH is generated. So now I have the two keys, my private key and public key, for whom the user called Shankar. Now this public key has to be copied into the other server, so that with the help of this private key and public key, I can connect to the other servers. So now here, what I'm going to do here, now I move to the destination server, which server I want to connect. So now on the destination server, the first step will be the user, right? Who is going to connect? The user called Shankar is trying to connect. So now here I'm going to create a user here, user add Shankar, and password also I'm going to set up Shankar. Done. Now once the user is ready here on the destination server, now to this guy, the Shankar, I would like to copy the public key from my source. Okay. So now to copy the public key, multiple ways again. There are multiple ways we can copy the public key from one server to another server. Okay. So I will show you the multiple ways. The first way, the safest way. The first way is the safest way. So nothing but you are not going to miss anything. Right. So now, so to copy in the first way, what we can do here is we need to enable a property from the SSH configuration. So to copy the public key, we need to change a property in the SSH configuration file. Right. So now here I will I will go to my destination server. This is my destination server right now. I have created the user and set up the password. So now here the configuration file of SSH you can find in the directory called etc, and under the etc you are going to find one more directory called SSH. So now you will be having a parent directory called etc. Under the parent you are going to have a child directory called SSH. Inside that SSH we are going to see a file called sshd_config. This is the configuration file for your SSH service. So now here I am going to change a property here, vi sshd configuration. So here search for password authentication. Password authentication by default will be no. Right. So why I'm going to enable the password? Because my concept is without password, I would like to connect the servers. But here I'm going to change the property. Why? Means first time, right? First time I'm going to connect the other server because I need to copy this public key. I need to copy the public key from my source to destination. Right. So how you are going to copy the public key? Right. You need to connect the server, then only can copy the key. Otherwise, you cannot copy the key. So now, first time, whenever you want to establish the access mechanism, by that time you don't have the private key and public key concept. Because of the reason I want to copy the public key. So now I require to connect the server. There I am going to use the username and password mechanism to copy the public key. So now I am going to establish the communication between the servers with the help of username and password. Then I am going to copy this public key into the other server. Once the key is copied, then I am going to disable that username and password mechanism. So to copy the public key into other server, I am going to enable the password mechanism. Once the key is copied, then I am going to disable it. Then I am going forward. I am going to use my SSH mechanism to connect the servers. Right. So that is the reason I am going to change this property. Password authentication by default it will be no. So now I am going to change it to yes. That's it. Right, so now here I have changed the password property, then save the file. Right, so SSH service configuration file I have changed it. So to apply the changes immediately, we require to restart the service. So to restart the service, the command will be service, correct? Then the service name SSHD, then restart. Right. Changes are done and restart the service. Now go to the source. Go to the source where the public and private key are created. From the source, now try to copy the key into the destination. So now here I am trying to copy the key. So to copy the key, the command will be ssh copy id is the command. To copy the public key from the source to destination, the command will be ssh copy id. Then followed by username, right? Who is the user here? The user Shankar. At the rate, which machine you want to connect? Which machine you want to connect and you want to copy the key? My destination server. So I'm going to take the destination server IP. 166 is the IP. Here, whatever the IP is displaying here, that is the private key, not the public key. 174, right? So 172.31.28, 174 is the IP. So if I go to my dashboard, here it is showing 166, nothing but the public key. If I scroll down here, you can see the private IP. So this is the IP displayed on your console, right? So yes, so we are on the same machine. 174 is my destination server. So the server public IP is this one, right? So I'm going to take the public IP. Any IP we can take. You can connect with the private IP or public key. It's not like only public key we need to use. You can take any. We can take any IP. So now here I'm going to give the destination server IP. Hit enter. Give yes. Now it's going to ask you the password because, right? So as I said, first time we are going to connect, right? So to connect, we require the authentication, right? So the authentication, I'm going to use the password authentication, right? So now here I'm going to give my password, the user password, enter. Now we can see total number of keys added 1, right? The public key is copied, right? So how we are going to confirm the public key is copied on the destination server, right? So let's go to the destination server now. Right, so here, right, the user Shankar is using here to connect the servers, the communication for the communication between the server. The user called Shankar we are using here. So let's switch to the user called Shankar. Su Shankar, then cd. Now I'm on the home directory called home Shankar, then ls-a. Right, on the destination server, I did not create any private key and public key. Simply, I have created a user and set up the password. That's it. So when I use the SSH copy ID command from the source side, automatically on the destination server, the hidden directory will be created, .ssh. So now let's go to the .ssh. Here, you are not going to see any private key and public key like ID underscore RSA on the destination server. You are going to see a file name called authorized underscore keys. You are going to see a file called authorized underscore keys. Then try to open the file. Right. So now here you are going to see the public key. So let me go to the my source. If I take the public key here, ssh-rsa, and at the end Shankar at the rate 63 is the IP. It is going to end here. Now if I go to the destination server, ssh underscore -rsa, then here you can see Shankar, same. The same key is copied here. Right. So the easy and safest way means you are not going to miss anything. Your command will be taken care. The command is nothing but ssh-copy-id. Now the communication, right? The copy key is done. Now we can establish the communication. You can connect to the server. So I will go to the source. Now I will try to connect the destination. So to connect the destination, the command will be ssh then the username Shankar @ the destination IP, right? So this is my destination server, which I want to connect. Enter. You can see here, when I am trying to connect, by that time, I am with the 63 IP. Now here I can see 174. I connected. From my source, I connected to the destination, right? So here ls, as of now, here I am not going to see anything. It is empty. So I am going to create a file here, .sample. Without connecting the other server, you are trying to perform the operation from your source. So now this sample file I am going to create on the destination, not on my source, not on my workstation, right? So now if I go to my destination server and if I give ls, I can see the sample file. So likewise, we are going to use the SSH mechanism to connect the other server securely and to perform the operations. You don't require to go each and every server and connect and do the operations. From your source, from your workstation, you are going to connect and perform the operations, right? So this is the way to connect the servers with the help of SSH, right? So one way to copy the public key is with the command called ssh-copy-id. The second way, you don't require to do any configuration changes, right? What I did here, I am using the password mechanism to copy the public key into the destination. So that is the reason I went to the SSH configuration file. There I have changed the property called password authentication as a yes. In the first way, with the help of ssh-copy-id command. Now the second way is not required to change anything. You don't require to change any configuration files. Simply what you can do here is on the destination server. So right here, I'm going to create for sample sake, I'm going to create one more user add DevOps. So now I'm going to switch to the DevOps. So now here what I will do, first I'm going to create a directory .ssh ls-a. Then inside the .ssh, I am going to create a file cd.ssh touch. Right, so now inside the .ssh authorized file, now whatever the public key I have generated on the source, okay, we are on the destination, exit, then ls-a cd.ssh cat id underscore rsa.pov. So now what are the public key you have generated here? Copy the public key manually. So manually copy the public key and go to the destination. But here I have created authorized underscore keys. Open the file and paste it. So this is the second way. So manually we are going to copy the keys. So when you are trying to copy the keys manually, you don't require to do any changes, the configuration changes. But here the problem is if you miss any character, a single character, it is going to throw you permission denied. Carefully we need to copy the public key and paste it. So like multiple ways we can copy the public key from one server to another server with the manual way or with the command. Right. But the end, the communication part will be the same. The mechanism will be the same. SSH, username and password. Right guys, clear? Any doubts here?
Clear.
Yeah, cool. Right. So now
Shankar,
here, yeah.
can we do vice versa, like connecting from this server to that server?
No. Vice versa will not be happen. Right. So only the logic here, what we need to observe here, copying the key, which key you are going to copy? Public key only. Right. So now here when I'm going to connect the server 1 to server 2, suppose, let's go to our picture here. So now here in my server 1, Shankar is having private key and public key. Now from here I want to connect the other server. So that is the reason what I did. For the same user, I have copied this public key into there. Then from here I'm going to connect. The connection will be established. That's what we have seen right now. Now I would like to connect from a server 2 to server 1. Right. So now the server 2 will become as a source. Now your server 1 become as a destination. So on the source, your mandatory one is private key. Right. So now when I'm going to connect from one server to another server, from the source to destination, now what the source will do, it will try to communicate the public key with the private key. So what are the private key I'm having here is trying to connect to the public key. These two keys are going to communicate. Then once they are matched, then connection will be established. But when I'm trying to connect to the server 1, where is the private key? You don't have the private key. So you cannot. Right. Now, if I want to do the same, then what I need to do here is I need to take the private key on the server 2. Then from that connect it. Yes, then it will be happen. That only the logic what we need to follow here is from source, whatever the source mission you are going to take and whatever the destination you want to connect, on the source mission, you must and should have the private key on the source mission. And on the destination mission, you must and should have the public key. Then only the communication is going to happen. If you don't have the private key, you cannot. Right. So the server 2 is not having the private key, you are not going to connect. So copy the key and you can connect it. Clear?
Clear, Shankar.
And Shankar, by using this public key, so I can connect to the n number of destination servers, right?
Yes, and like the only concept here is just whatever the servers you are trying to connect on the server, the user is required and the public is required. That's it.
Okay.
Then you can connect. We are going. That's so the practice. What we are going to follow in our real time also the same. We are going to connect with the one user only with the n number of servers, say hundreds of servers or thousands of servers. The same. There is no difference. Right, guys? So if you are good, we'll move to our Git.
Yes.
Okay, cool. Right, so let's go to our topic. So I'm going to terminate these two servers right now. We don't require. Guys, when your practice is done, please stop your server so that we can save the hours. Otherwise, in the background, the machine is going to run. It is going to consume the hours, our free hours. Okay. So if anyone like anyone account is charging like right now my account is charging 230 rupees. That don't be panic. Don't need to pay anything. Simply we can close this account and you can create a new account. Okay. So don't pay anything here. So if you are getting any amount, so let me know so that I will tell you how to close this account. Okay. So but anyway for our practice, 750 hours are more than enough. So usually I'm not going to get, but yes, one time we are going to get because we are going to use some other high confidence server for the Sonar queue. But anyway, we can close the account and we can create a number of accounts. So that is not a problem for us. So let me go to our Git. So I'm going to connect the server which I have created yesterday. So in our yesterday class, we have discussed about the Git and we have discussed about the GitHub. And Git, we have created the repository locally, and we have seen how to how to save the code and locally, and how to see the history and those concepts. The same concepts we have repeated on the GitHub side also. So GitHub side, we have created a repository. On the GitHub side, how to manage the code, like taking the code from the GitHub to local and push the code back to the GitHub once the changes are done. Right. So the process will be, when you are going to deal with the GitHub, the steps will be, right. The first step will be clone the code, clone or pull or fetch, right? We know what is the clone and what is the pull. Then the second step will be on the local, do the changes, and the third step will be add, fourth step will be commit, and fifth step will be push. So these are the steps which we need to follow. So to get the code from the GitHub and work with the code and push back the code to your GitHub, right? So now let's see the options. Apart from these main options, whatever the options we are going to have, let's discuss about those options. Then we'll see the flavor, like the other commands which we need to follow, in our real-time practice. So this is not the real-time practice which we need to follow. Actually, there is a separate process. But so now, if you want to manage the code between the GitHub and local, these steps are enough. These commands are enough. Okay. So let's see the other commands first. So now here, if you guys go through my PPT, here I have explained the working tree. Inside the working tree, whatever the directories are there and what the purpose of those directories. And we have seen the bare repository, and this is the GitHub part, how to create the Git repository on the GitHub side. Right. So yes, these concepts not covered yet. We'll see right now. And cloning. Right. So now this is a separate process. I will let you know, guys. So here, yeah. So still so many comments are there. We'll see anyway. Right. So now let's see here. When I want to deal with the GitHub, the first thing will be on the GitHub side, I required a repository. Right, when I want to deal with the GitHub means I require a repository on the GitHub. Then whatever the code I want to manage, the code I am going to push into the GitHub repository. So for that, what I did is yesterday I have created a repository called DevOps repo. So let me log into my account. DevOps repo is created yesterday. Right. Here, with the help of new repository option, we have created a repository called DevOps repo. Now, this repository I cloned into my local, then I manage the code inside the repository, like daily backup. Now, I would like to create a GitHub repository from my local. So now, when I want to create a repository on the GitHub, I am going to connect to the GitHub. Like I logged into the GitHub, then I went to the option called new repository, then I created it. So now, without going to the GitHub, I want to create a repository from my local, from my workstation. Okay. So there we don't have straight away GitHub commands. There is no straight away GitHub command. We are going to use the APIs. With the help of APIs, we can create a GitHub repository. Okay. So this is like entry question, guys, not for the real time. Just we'll go here and we'll create it. But anyway, yes, options are there, ways are there. Okay. Right. So here, if you want to create a repository on the GitHub side from the local, from the workstation, then the API will be github.com api.github.com users repos-d. So this is the method which we are going to call to create the GitHub repository. Okay. The command which I am going to use is curl command. Right. So now here the curl, I think you guys are I don't know. The curl will be nothing but like when you want to get the content from the internet, when you want to download the content from the internet, we can use the command called wget. Actually, wget is the command to download the content from the internet to your local. from the community to local. When I want to push the code from my local to community, nothing but the destination, like my internet location, right there, the duplicate will not be works. The duplicate purpose is to download, not for to push. The curl can be used for to both. You can download and you can push. You can send a request and you can get the response. The curl, right? So now here I'm going to send a request to the GitHub. So now the request is nothing but to create a repository. Right? So now here let me take the command. So now here user, the curl command, when the API is going to call here, the first part will be the username and the last part will be the repository name. Right? So these two arguments we need to change. The rest will be remains same. We should not change anything here. Right? So now here I'm going to take curl. So now here I'm going to give the repository. So repository here I'm going to give Ansible repo, some name, my repository name. On which account you want to create, right? So because on the GitHub side there can be have many accounts. The GitHub can be have many accounts, right? Out of all the accounts, which account you are going to use to create this repository? So I would like to create into my account. So my account username will be this one, your GitHub account, GitHub ID. So now hit enter. It's going to ask the password for the GitHub ID, GitHub account, right? So now here I'm going to give my password, my account password. So now if the API call hits successfully, then we are going to see the response, something like that. It means the repository is created. So let's go to the GitHub, refresh, go to your account, click on your account. So now here you can see there is an option called repositories. Click on the repositories. Ansible repo, 7 seconds ago. Just now I have created it. So like that, we don't require to go here and create the repository from the GitHub side. Simply we can create a repository from the local with the help of the API, right? So that is the purpose of API here, creating a remote repositories from the local. This is the API call, and here we need to provide the repository name, and here we need to provide the account holder who is going to have that repository, right? So now let's go to the other part here in the slide, ignoring the files, right? So now here, yesterday we have created a repository, DevOps repo, right? So now this repo we have created yesterday, and we have placed some content also, nothing but the Jenkins daily backup data sets. So now whenever you are trying to do any operations on the repository, the first thing will be you must and should make sure your remote and the local both are in sync. Then go for the operations, go for the changes, whatever you want to do, right? So now what I'm going to do here is to make sure both are in sync. Simply I'm going to run the command git pull, right? Git pull is the one which is going to try to pull the latest code from the remote to your local. So now on the remote side, no latest code is there. So that is the reason I can see up to date. Both are in sync. Now, once you got the confirmation, then go for creating do the changes. Right. So now here, I am going to create a file called tracking. So I want to track my changes. That is for my internal purpose, not for everyone. Okay. So now for that, what I'm going to do, touch my track. I'm going to create a file called mytrack.txt. So now I want to track my changes, what I'm going to perform on daily basis. So those changes I want to put in a file called mytrack.txt. This is only for my internal, not for everyone. So now if I see here ls, mytrack.txt file is created. So now here in the file, I'm going to add my tracking, my information. So right, so today, like on 21st 6th worked on backup script. So like I would like to track my changes so that when I want to verify anything, simply I will go to my track file and I will say, okay, this on this day I did so and so changes like that. So purely for my internal purpose, not for everyone. Right. So now if I place this file in the GitHub, like in the repo called DevOps-repo, when I push the changes, my file will also go to the GitHub side on the remote side. So means that is for everyone. So when the moment the file go to the remote server, nothing but the GitHub, so now it will become a public. Public means everyone can see your file, right? So now here the alternate way is, so don't put the file, don't put your tracking file in the repository, put it separately in separate location, so that so that this file will not be go to the remote. But I don't want to do like that. I don't want, because I may forget that file location, or sometimes I may forget to update the file. If I have the file here, so that I can, okay, I know like my file is here, so I can do the changes, that I can update the file like that. So my intention is I want to have the file in the local, in the repository itself, but I don't want to have the file in the remote side. So I want to maintain the file in the repository, but I don't want to have the file in the remote GitHub repository. Not to have means no one should take the file, right? So for that purpose, the Git is providing a file called .git ignore. So when the .git ignore is the concept in the GitHub, is nothing but whatever the files or folders which you don't want to share to others, which is not required, those files can be hidden. Those files can be hidden in the GitHub repository, so that when the moment the people are trying to clone the code, they will not clone those files. The GitHub will not give those files. Okay. So let's see how to deal this one. So now for that, what we need to do here is, we require to create a file called .git ignore. So now here I'm going to create, dot means hidden, a hidden file I'm going to create with the name called git ignore. So touch .git ignore is the file we are going to create. Enter. Now ls, because it is a hidden file, you are not going to see with the ls command. The option which we require to use is -a. Now I can see a .git ignore file is created. So now here in the file, in the ignore file, we need to tell whatever the files or directories which you don't want to push into the remote server. Those files information we need to provide in the .git ignore file. So now here I don't want to push my file called mytrack.txt, but I want to have in my repository. So now here what I'm going to do, I will modify the .git ignore file. Then in the file I'm going to create an entry, nothing but my file information, mytrack.txt file. So this file I don't want to push it. So now here the file I have added in the .git ignore file. The entry is created. Then save the file. Right, now see here, let's try to check the status, git status. Now here you are going to see only .git ignore, no mytrack.txt, right? Mytrack.txt also a new file which just now I have created, but the git is ignored because I have mentioned this file in the .git ignore. I am asking to ignore this file to the git, so it is not showing the entry of the mytrack.txt file. It is showing only the .git ignore. So now the process will remain same. Changes are done. Git add git commit -m mytrack file is created and added in git ignore. Now git status, you can see working tree is clean, so that you can push it. Git push, my username and the password. right? Master to master, that the code has been pushed. Now go to the GitHub and open the DevOps repo. Now you can see here only the .git ignore, no my track.txt file, right? So the txt file is not moved, not cloned into, no, sorry, not pushed into my GitHub. So now if I open the file, there I can see what are the files are ignored here. So now I can find, okay, here I can see my track.txt file is ignored, but I cannot open this file. This is not a file. This is just an entry in the file. Means you know the information, what are the files are ignored, but you cannot take those files. Right. So usually developers, right, when you are trying to implement the applications, by that time some configuration files are required some point of time. Some point of time those files are not required. That means, right, some point of time the files are required, so that you need to build the application, you need to create the package with those files. Later those files are not required, but again you are going to use those files in the future. So then instead of deleting the files from the repository, we are going to ignore the files. We are going to push those files into .git ignore. Then build the code so that the files will be ignored. When the moment I want those files, simply I'm going to remove those entries from the .git ignore. Then those files will be back. Like, so developers are going to use widely this .git ignore, this concept. Okay, anyway, so whoever is going to use, the concept will be the same, nothing but whatever the files we don't want to have in the remote, so that the other people cannot take those files. So that process is nothing but the .git ignore, placing the files in the ignore file. Right, guys? So now let me go to our slide again. Yeah, so the process I have explained here. Git log. So git log is the command which it displays the history, correct? So when I hit the log command, when I enter the log command, it will display the entire history of the particular branch. Now what is the branch here? Master. So now here the message, whatever the message I have passed it here is not clear, or it is not required actually. So I want to modify the message. Message means the commit message, right? So when you want to change the commit message, so right there we are going to use a command called git commit hyphen amend. Git commit hyphen amend is the option to modify the commit messages. So let me take the syntax, check the syntax here. Git commit hyphen amend, then hyphen m and the message, the new message. Right. So here only the latest message it will take, and it will modify, not for the older ones. So now your messages, your commit messages can be modified for the latest one only, not for the older ones. Right. So now if you want to modify the commit message, the command will be git commit hyphen amend is the option. Then hyphen m, the new message. So now here git ignore added. I am trying to modify the message from my track file created and added in the git ignore to git ignore added. Right. So now if you guys remember, I told you, like, when the moment we are going to hit the command called git commit, it is going to generate a new commit ID, right, for the change. So now here already I have done some changes, nothing but I have created a file called mytrack.txt. Then that file I have added into .gitignore file. For the change, I have created this commit, this message. For the change, I have given this message. Right now here again I am trying to run the command commit, means it will try to generate a new commit ID. For whom? For the same change. For the same change means for the .gitignore and the mytrack.txt file. Right. So now here what the Git is going to do, when you hit the commit command, it is going to generate a new commit ID for your change, for the same change only. It is not going to do any content change. For like whatever the data you have changed, for the data, whatever the commit you have generated, it is going to change the commit ID, not the data. It is not going to touch your data, but it is going to change the commit ID, because Git never maintain any duplicate commit IDs. It never ever maintain duplicate commit IDs. When the moment I am going to hit the commit, it will try to generate a commit ID. So now when the moment it is going to generate the commit ID, it is not going to use the same commit ID, because Git never have the duplicates. So now it will generate a new commit ID, but for the change will be the same. The change nothing but my track.txt file and my ignore file. The data will remain the same, but your commit ID is going to change, because I am going to hit the command git commit again. Let's see. Here you can observe 454 is the commit ID. It is going to start for this change. Enter. Right. So now here again run git log. 454 is changed to some 5DA and git ignore is added. The commit message is changed. Right. So likewise, we can update, we can modify your commit messages with the option called -amend. Git commit -amend, then followed by -m the message. Right. So now data cloning and pushing. Right. So taking the data from the remote called GitHub into your local and push the data from your local to GitHub. We have seen that mechanism. We have seen that process. Right. We have taken the path of the repository, cloned it, done the changes, and pushed it back to GitHub. Right. So now so that is the first, that is the one way which we have followed. Right. So the process, the way is called HTTPS mechanism. Right. Yesterday process, whatever we have seen, that is HTTPS mechanism to get the code and push back to your remote. Right. So now let me go to our GitHub. So I'm going to click on the repository, DevOps repo. Here you can see a button called clone or download. Right. From here only we have taken the path. So now click the button again. Now you can see here the path. We can observe HTTPS, clone with HTTPS. Right. So when you use the clone mechanism with the HTTPS method, always you require to give the username and password. Right. So now there is another way to handle the code from the local to remote with the help of SSH, secure shell mechanism. Right. Just now only we have discussed about the SSH. Right. So now, right, what is the advantage? I will let you know. I will show you what is the advantage between the SSH and the HTTPS. Right. So advantage not between over the HTTPS. What is the advantage with the SSH? Right. So now here, right. So now the methods, the ways to handle the code between the local to remote. One is HTTPS, and the second one is SSH. Now let's see. HTTPS already we have covered. So now I'm going to cover the SSH one. So now to handle that SSH one, you should not take this path. Switch to the SSH. So here you can find a option called use SSH. So click on SSH one. Now here you see the path is changed. Now here you can see the switch use HTTPS. Click on HTTPS. You can see HTTPS. Now you can switch to SSH again. Click on use SSH. The path is getting changed here. Right. So now I'm going to use the SSH method to handle the code between my local to remote. Right. So clone the code, copy the path, go to your machine, your workstation. So now the same repository I'm going to clone. So already the repository exists. So it is going to throw me an error. Already the repository exists. So that is the reason I'm going to delete this existing one. So rm is the command to delete the content, right? rm-rf. DevOps repo. So now the repository is deleted. So now I'm going to clone, right? To clone the code, command will be git clone. Now the method which I am going to follow is ssh1. So now git clone the path, copy the path and paste, enter. Yes. Now it is going to throw me an error. So now here I am trying to use SSH mechanism to get the code from a remote to local. So now when I'm going to use the SSH means I require the private key and public key. Without the private key and public key, I cannot use SSH. That is the reason here it is going to show you. Make sure you have the access rights. Permission denied, public key. It is not able to find any public keys. Simply it is throwing an error. So now the process is, first you need to make sure the private key and public keys are placed between local and remote. Then go for the SSH mechanism. Right. So now here what I'm going to do here is I'm going to establish the SSH mechanism. Then I'm going to use the SSH mechanism to get the code into my local and push the code to remote again. Right. So here we have seen I have taken two servers. Right. Then on the server one, I treated the server as a source. On the server one, I created a user called Shankar. And for the Shankar, I have created a private key and public key, and I copied the public key into the remote. Then I connect it. But here we don't have two servers. That one is your local, and the second one is your GitHub, the cloud. You don't have any physical servers, any virtual machine. You cannot connect the server. It is a completely GUI stuff. It's a complete GUI. Now, how we are going to handle this case? Right? I will show you. So now the first thing will be, again the process remains same. Process is not going to change. SSH process is not going to change. Right? So now here as part of the process, the thing will be you require a user. The user has to have a private key and public key on the source machine. Right now I am going to my source. Now this is my source, nothing but my workstation. On the workstation, I am going to create a private key and public key for the user. So right now I am going to use the user called root. I am working with the user called root. So now for the root user, I am going to create the private key and public key as part of the process, SSH process. So SSH -key gen. Enter. Right. So same. Now what will happen here? For the user called root, it created two keys, private key and the public key. The same process, no change here, right? So cd.ssh just for confirmation. Now ls, I can see two keys. Now this public key, now the connectivity part. When you want to connect to the remote, on the remote server, the public key has to be copied. So now here it's not a server here, it is a cloud one. Means somewhere on the cloud, the server exists. On the server, the GitHub is installed. Now we are going to access the application, not the server. They are not going to give the authentication to connect the server. Simply they are going to give the authentication to the application, this GitHub application. So now here we require to the copy the public key to the application only, not to the server, because I'm going to connect to this GitHub only, not to the server. So now here I will go to my user here. So my user here is this guy RAKNH999. So now here I will go to the user. Then there you can see last but one option called settings. Click on the settings. Now you can see here in the left pane there is an option called SSH and GPG keys. So click on the SSH and GPG keys. There's some key is already there. I'm going to delete this key. So now here you are going to see this menu, this option, this dashboard, SSH keys and GPG keys. So now here you can see a button called new SSH key. So click on the button. Now give some name. So I'm going to give the name called AWS-key. Some name, anything your wish. Now go to your workstation. wherever the keys are created, open the file, right? Remote means the public key has to be copied, not the private key. So open the public key. Okay, now copy the key, go to the GitHub again, paste it here. Now click on add SSH key. That's it. So now the public key is copied into my GitHub, into my remote. Now I can use the SSH mechanism to get the code into my local. So I will go to the local, my workstation again. Here I am going to run the command again, the clone command, git clone. Enter. Now see, the code is copied. ls. You can see the repository. Right. So now go to the repository, do some changes on the repository side. So I am going to modify the readme file. Some changes cloned with SSH. Save the file. Changes are done. Then the next commands will be the same. Add commit, right? Git status. Untracked state. The new changes are in untracked state, right? Git add, then git commit. Now once the add commit is done, the final step will be push. So now git push. Now the observation will be, when you are going to use the HTTPS mechanism, when you are trying to push the changes, you must and should enter the authentication username and password. Here you don't require to enter anything. Automatically your SSH will be taken care. Right. So authentication process, username and password is the irritation process, right? Because multiple times you are going to commit, multiple times you are going to change, and multiple times you are going to push the code. Always you require to enter the code, the authentication details again and again. That's that irritation process for us. So now SSH is the safest and the easiest for us, right? It won't ask you any authentication details. Automatically the private key and public key are going to communicate. Right. So this is the second way of handling the code between your local and the remote machine with the help of SSH. Right, guys? So these are two ways which we are going to use from the GitHub side to handle the code. Right. So if you want to go to the home, simply click on the cat symbol. From any page, you want to go to the home. So now let's try to understand how this Git, your local and the remotes are going to communicate. Okay, so when you are trying to push the code, how these local and remote are going to communicate, so that this code is going to go to the same user, right? So now here, if I see, there are n number of repositories, and the GitHub and the github.com, you can have multiple accounts. This is one of my accounts, right? So when the moment I'm going to hit Git push, straight away it is going to connect to my account, and it is going to connect to the same repository, whatever the repository I want to push. Right. So how the Git will know exactly it has to go to that account, and exactly it has to go to this repository. Right. How your local machine knows it has to go to the same repository and the account called RAKNS999. Right. So now here the system will understand with the help of remote paths. your local machine will understand with the help of remote path, so that it will take the remote path. With the help of the path, it will go and hit the account, and it will go and hit the repository of that particular account. Right. So now how we are going to know? So to see that information, git remote -v is the command. So when I hit the command git remote -v, it is going to show me the remote GitHub repository path details. Right. So now here you can see github.com. Under the github.com, this is my site, my account. Under my account, this is the repository. So that is the reason when I'm trying to run the command git push, in the background it will take the path, this one. So the path will tell the git like go to this account and push the changes to this repository. So it won't touch any other repository of your account. Simply it will go to the same repository. Right. So now how the path came into your local, these paths. When the moment we clone the command, moment we clone the code by using git clone. So automatically the remote path will be added into your local. Into your local means what are the repository clone? In the repository, your git automatically will be added this remote path. We don't need to do any changes here. So automatically your git will be taken care. So now we are going to see two entries here. The two entries are nothing but one is for the fetch, nothing but the pull. One is for the push. Get the code and push the code. So to pull and push, for the pull for entry, for the push one entry is going to create. Now here you can see here there is a name called origin. So now here the origin is nothing but the name of the repository. I mean to say the path of the repository, not the name, guys. The path of the repository will be treated with the name called origin. So instead of referring git@github.com, rakna / the repository name, simply we can call with the name called origin. Right. For the remote path, it has given some name. Again, the name also will be given by your GitHub only, not by you or me. Automatically, these will be created by your GitHub. Okay. So with the help of the path, this code can be handled between the local and remote. Right. So now what is the use? Why we are going to focus this remote path here? Because anyway the Git is going to maintain everything. Why should I go and see this information? Right. Yes, we require this information. So this is our real-time stuff and also interview area also. Give me a second, guys. Yeah. So now here my requirement is I have two repositories. One is DevOps-repo, and the second one is just now I have created one more repository, right? Ansible repo. Okay. Now I have two repositories. One is DevOps repo and the second one is Ansible repo. Now I want to push. I want to copy the code, whatever I'm having in the DevOps repo, means the branch. The master is having all these files. Now I want to push the master branch, the code, nothing but this code into my Ansible repository, into here. So as of now, this Ansible is a plain, is a empty repository. No files are here. Okay. So now I want to push the code from the DevOps repo to Ansible repository. Copying the code between the repositories. Right. So how we are going to do? Because if it is one file, simply I can copy the file from here to there. If there are thousands of files, then it is like you cannot go for manual. Right. So now in the Git, we can copy the code without missing anything. without missing the code anything. We can copy the code with the help of remote paths. With the help of remote paths, we can copy the code between the repositories. Right. Let's see how we can do. So now here I am going to take the path of the remote also means I am going to clone the Ansible repository also. So now here this is the HTTPS path and this is the SSH path. So now here I took the SSH one, copy, go to your local workstation. I am inside the DevOps repo. I am going to move out from here, come back. So now I'm in my home location. Now git clone and the path. Enter. Now you can see here Ansible repository is also cloned into my local and DevOps repository is also cloned into my local. Right. So now here if I go to the DevOps repo, I can see some content is there. If I go to the Ansible repo, cd Ansible repo, it is an empty one. Nothing is there. Now I want to copy the DevOps code into my Ansible. No manual copy. So I'm not going to do any manual copy stuff here. So here now I will take the remote path of the destination repository, right? My source repository is DevOps. From the DevOps, I want to copy the Ansible. The code of the DevOps, I want to copy into the destination repository called Ansible repo. So now I'm going to take the remote path of the destination repository called Ansible repo. Right. So now we know how to get the remote path. How to get the remote path of any repository. The command will be git remote -b. Right. So now here you can see this is the remote path for the Ansible repository. Now take the path, copy the path of the destination repo. Now go to your source. Now go to the source repository. Now simple what I'm doing here, I went to the destination repository. Then from the destination repository, I'm going to collect the remote path. Then I'm going to my source repository. So cd ... Now go to DevOps repo. In the source, whatever the remote path of the destination repository you have collected, here add the repository. In the source, add the remote path of the destination repository. Okay, right. So now for that, the command will be git remote add, then some name. Right, you can see for every remote path you are going to see some name called origin. Origin is the default name. Right, now here provide a name. So here I'm going to give a name called suppose Ansible. Then the destination repository path, whatever I have copied. So now in my source repository, I am going to add the destination repository remote path with the name called Ansible. To add the path, the command will be git remote add. Enter. Now let's try to see git the remote paths. Git remote -v. Usually you are going to see for every repository 2 entries. One is for the fetch and one is for the pull for the default one called whatever the repository you are having, you are in. Right. So these two. For any repository, you are going to see 2. Now I have added one more entry for my destination repository called Ansible. Now I can see Ansible repository. Right. Now copy the code from your source to destination. Right. So now the very easy that to copy the code between the repository. Once you got the path, once you collected the path from the remote and added into a source, then the command will be git push. So when the moment I ran the git push, it will try to connect to the default ones. So now the push is nothing but it go trying to connect the default one. Default is always origin. Default. So what is the origin here? My DevOps repo only. So now when I use git push, it will go to the default one. It will try to connect the default one, nothing but the source repository only. It will try to push the changes to your source repository only. But here my requirement is not the source. I want to copy the code into my destination, some other repository. So there you should not use the git push. Git push is not the sufficient one. You have to use the full syntax of the push command. The full syntax of the push command is git push, then the repository remote path names. So now here I want to push to the Ansible, my destination repository, and the remote path name is Ansible. So now I'm going to use Ansible. So now I'm going to tell the push command, go to the remote path called Ansible. So now here, what are the remote paths here? This is the one, nothing but the destination. So now which code you want to push, right? So I want to push the code of the DevOps repo of the DevOps. If I go to here, I want to push the code of DevOps repo. The code is here, 3 files. Under which branch? Master. So now I want to push the master branch code. The total code is resides under the master branch. So now you need to tell the name of the branch. Right? There is a chance of you can have number of branches. So out of all the branches, which branch code you want to push? Right? There is a reason here. In the git push command, it is going to ask you git push origin means which repository you want to connect and which branch code you want to push. So now as of now we have only master we are having, no other branches. So now I'm going to use the master only. Right. Here, one point we need to focus here. Right. So the point here is when I'm going to tell push the code to the master. Now we need to make sure the master, the branch, master means a branch. The branch should not be exist on the destination repository. Right. So if I go to my account and go to the destination repository, Ansible repo, and see any, right, it's a plain repository, empty repository, no branches are there, means I am good. Suppose if I have the branch, the same branch is exist on the destination. Now I'm trying to push the same branch from the source to now it won't allow you, because on the destination branch master, suppose if I take a master example, on the destination repository the master branch will be having some other code. Now in the source you are going to have some other code in the master branch. When you are trying to push the code from this master to that master, now the both codes are not will be in the sync, it will going to reject you. Conflicts, git conflicts, right? So when the moment, right, so always the best practice will be whenever you want to copy the code between the repositories, better to have a branch on the source that should not be exist on the destination, so that without any issues the code will be pushed out. If the branch is exist, there it will throw an error of conflicts, because destination will be having some other code, source will be having some other code. There is a chance. Okay, that's on here. So now here,
1 minute.
yes.
So for this Ansible repo, right? To have the branch, we should create a repository without README file, right?
README file, yes, correct. So README, when the moment you create a README file, it is going to create a branch
It will
called
create
master.
a branch. Yeah, okay.
Yes. So
Fine.
yeah, anyway, we have other ways. Means even if you create a README file, in other way we can push the code. Nothing but creating a separate branches. Now we are not at the branches side, so we'll see that process. But the practice I am going to explain you. Okay, but yes, whatever you are saying is correct. If you create a README file, means automatically the master branch will be created. So now there is a chance of conflicts.
Yeah, okay.
Yeah. Okay, yes. So now let me go to my workstation. Now git push. Now my remote path name called Ansible, then the branch name called master. This master is your local. Your local means source repository branch. Enter. See here, new branch. The master is not exist on the remote, so now the new branch is created with the name master. Let's go to your destination and just refresh it. See here, you can see the master branch came, 3 files came, total 6 commits. entire with the history, data, everything as it is copied into the other repository. Right. So if you do manual, there is a chance of missing many things. This is the process, the best practice and best process always to copy the code between the repositories. Right. Very simple. Destination repository remote path has to be added in the source repository, then push the changes. That's it. 2 steps. Right. So now the point which you need to make sure is better not to have the branch on the remote side. On the remote means the destination repository, so that without any issues the code will be pushed out. Otherwise you will see some conflicts. Okay, I will show you. I will show you if the branches already exist, then how we can push the code. Okay, I will show you when we are in the branches side. When we are in the Git branches, by that time I will show you. Okay, even though if the branches exist, then how can I push the changes? Right, guys. So shall we take a break here, 10 to 15 minutes, 10 minutes at least?
Okay, so one more thing. Shankar?
Yeah.
Yeah,
Hello.
if you want to move only some of the files, means if we have the 1,000 files, if you want to move the push the only 100 files, so how we will
So that will be a different process. If you want to push only 10 some files, you need to in the source, you need to take the files in a separate branch. Right, so there are 100 files are there. Let's copy the 100 files in a separate branch, then push the branch like that.
Okay. Thank you.
Yeah. So guys, right now the time is 11:42, right? So we'll meet after 10 minutes, 11:52. Is it fine? Yeah.
Okay.
Yeah. Yeah. Thanks, guys.
This conference will now be recorded.
Yeah. So now here let's try to discuss about the branching strategy. Then we'll go and see how to create the branches and how to handle these branches with the examples. Right. So now if I take the CI/CD process, so usually you are going to have different environments. When the code is ready, the final goal of the code will be deploying into the production servers, right? So that the customers can access your latest changes. Right. So now once the code is ready, it has to go to the production. So now straight away it will not go to the production. There might be many issues you are going to face if you deploy the code into the production straight away. So that is the reason we are going to perform many checks. So in the many checks, the checks are nothing but you are going to check the performance of the application. So that you are going to make sure the latest changes are not impacting your performance of the application. As an example, before the changes, if I hit the application, the response time is 0.01 second. After changes, the response time becomes 0.02. So we are not going to accept the changes. Simple, right? So because of the reason, you should not face the impact of the performance. Right? So that is one check. And then the load, like if the changes, is there any impact on the load? Like if the users are trying to hit on the application, like 1,000 users or 1,500 users, any impact. And the other check will be your change is not impacting, not causing other services are went down or other services are facing any issues. It should not impact the other services, your changes. The flow of the application we are going to check. So likewise, many checks we are going to perform before going to the production. If all the checks are passed, then finally we are going to deploy the code into the production. So now to perform these different checks, we require servers. Right, on the servers we are going to deploy the code and we are going to perform the check one. Fine, then move the code into the second area, the second environment, then do the other checks. Like that the code will move to different environments and validations are going to happen. All the validations are passed, then it will go to the production. Right. So for that purpose we are going to use the environments. Now we are going to call in the technical term environments. So now here if I take, suppose these blocks as environments. So now here, this is my development environment. If I take this one as a development environment, and this one I can take it as a QA environment. This I can take as a user acceptance environment, and this is finally my prod environment. Right now, these blocks I'm going to consider as environments. So now we are going to perform the validations on these environments. Then finally we'll go to the production. Right. So now here, when you are going to validate the code on these environments, what we are going to do here is, in the process, whatever the code has been developed by the developers, the code will be pushed to in the first of your source code management, SCM, nothing but the Git SVM or something. Now the code will be placed here. So now here, once the code placed to your version control tool, now our DevOps process methodology, nothing but the CI/CD is going to trigger here. So now your process is going to trigger. Then in the process, the first part will be take the code from the version control tool. In the project, what are the version control tool you are using? You are going to connect to the version control tool, and you are going to take the latest code. You are going to take the code. The code is nothing but including your latest changes. Then once the code you push it out, in your process, you are going to build the code, right? So now we are straight away we are not going to deploy the raw code. Like suppose I have implemented a feature on the credit card. For the credit card, we are maintaining a file called cc.java as an example. So now we are not going to deploy the cc.java like as it is. We are going to convert that file, the raw file, as an artifact. That artifact will be deployed into the web servers like Tomcat, JBoss, Apache, like that. Right. So now your environments are nothing but the web servers. If I take it as a web servers, now the environment will be having a web servers. On the web servers, we are going to deploy the code. Right. So these web servers, deployments, environments, we'll see like when we are doing a project like the CI/CD process. So now our focus is branching strategy. So now here, now my code is ready on the GitHub or version control tool. Now I have to take the latest code and I need to build the code. And once the code is ready, once the package is ready, then I need to deploy the package into my first environment called develop environment. Right. So now here, then once the code validation is successfully completed, on the develop branch, then the second level of validation will be performing on the QA environment. The next level, first level of validation will be on the develop, and the second level will be on the QA, quality assurance. Right. So now here again, now we are going to take the code and build the code and deploy the code into the QA environment. Right. So now the QA environment, on the QA environment, you are going to validate the second validation. If everything goes fine, everything goes fine, then we are going to.
Hi Shankar, just interruption. Radha system is getting restarted. Can you please pause for 5 minutes?
Yeah, sure.
This conference will now be recorded.
Yeah. So the branching strategy is very, very important for us for the interview sake and for the real time also. Real time in the sense of our projects. So now usually we'll be seeing environments like dev, QA, UAT. In between, we are going to see one more environment called system integration testing, SIT. Right? The environments can be vary, like based on the project, it can be 3, it can be 2, or it can be 4. That is fine. So now our focus is not the environments. So now our focus is the branching strategy. So now on the environment level, how the code is going to deploy. Right. So now we know the code will be placed on the version control tool called right now Git or some other control tool. So now here from that Git, we are going to take the code and we are going to build the code. Building the code nothing but converting the raw code into packages like jar files, war files, or DLL files, or exe files. Those files will be deployed into the servers. That is our CI/CD process usually. So now we are not going to take always the master branch code. Now, master branch code is not going to pick always to deploy the code into the environments, right? So now why? Because the master branch is the one which is going to have the stable code, nothing but the production running code. If the people are trying to push their changes into the master branch, then there is a chance of mess ups, right? All the development code is, we cannot give the guarantee like those are properly developed, all the development code. So there is a chance of it can be it can be lead to memory leaks. It can be lead to, even the code is properly developed, but there is a chance of memory leaks can be happen, performance can be downgraded, right? Or it can be impacted the other services. There is a chance because the person, the developer, will focus on the requirement. He is not going to focus on the other areas like performance things, memory things, and the other services impact, right? So now when we are going to come to know, when we are going to validate the code, so now his job is, his or her job is develop the code as per the requirement and give it the code to the process, like validation. So now during the validation we are going to verify, we means the testers are going to verify all the stuffs. Now if they, now if all the checks are passed, then they are going to give the approval to go to the production, otherwise push back, right? So now that is the reason we never push the development code straight away to the production, nothing but the master. Master is always stable code, nothing but the production code. So that is the reason we are going to maintain different branches. So to maintain the segregation so that it should not impact your production codes, production or some other thing. Right? So now here for, right, so now here we'll be having a repository, we'll be having a version control tool like Git. So now whatever the code is developed, the code will be pushed to any one of the repository. Now that suppose as an example, if I take a banking application, now the banking application, now we are working with the ICICI, suppose ICICI Bank, we are going to develop an application. So now you are going to create a repository for the banking called ICICI, like ICICI-repo, something like that, right? So now all the code belongs to the ICICI Bank will be pushed to the same repository, something like that, Ansible repo, something like that. So now here, now when the moment developers are pushed the code to the version control tool, in the version control tool, one of the repository, like whatever the project they are working. So now in the version control tool, we are going to have a repository. Now we know what is the repository here, right? So now here the code will be pushed to the repository. So now your process is going to pick the code from the repository. Now in the process, first level will be the development environment. The code has to be deployed into the development environment. So now here, the people, the developers in the repository, they are going to push into branches. Now here, we are going to maintain for the repository different branches so that it should not mess up the things. So now here, my first branch will be in the repository. My first branch will be the develop branch. So now this is the repository, and under the repository, my first level of branch will be the develop branch. So now what the developers are going to do when they got the requirement, right? We are going to follow the agile process. Agile is nothing but divide the entire code into pieces. Code means our application to pieces. Then work on the pieces level, nothing but the iterations. Iterations levels we are going to work. Now we are going to call it sprints. Like the sprint will be 2 weeks span, 15 days. 15 days, 15 days, we are going to implement the code, we are going to validate, we will push like every, like iteration model we are going to work, right? So now once they got the requirement, what they will do, they will take the code from the version control tool called Git, as an example Git. So now they will pull the code, right? We have seen clone, pull, fetch. They will take the latest code from the repository. Then they are going to start working on that code, right? So here, if I take here, if I go here, if I go to my workstation, I am at the DevOps repo. So now Git pull, so that I'm going to make sure my remote and the local is sync. Yes, both are sync, means I have the latest code. So now straight away, I am not going to do the changes like this. Now I am a developer. I am not going to do the change like this. Right? Whatever process I have showed you, this is not the real-time practice. So that is a process to maintain the code between your local and remote. But in the real time, no, we are not going to do like that. Right? So now here, straight away, we are not going to do the changes. There, the branches will come to the picture. Right. So now what the developers are going to do, once they got the changes, once they got the latest code into their local, they will create a new branch. Those we are going to call as a future branches. So now the people, the developers will be created future branches on the latest code. So now suppose this is my development mission. So now future 1. So now this is the branch, nothing but the replica. Branch is nothing but a copy of the code. Right now my master is the latest production code. Now we'll see how to create the branches. So now for the master, I'm going to create a duplicate with the name called future 1. So now on the future 1, I will be having all the code of master. Then I will start implementing my requirement. I'm going to develop my requirement on my own branch called future 1. So now this future 1, once the future 1 is ready, means my coding is done. Then what I will do, straight away, I will merge my future 1 to the first level branch called develop. Now I am the developer. So now what the developer will do, he will take the latest code. From the latest code, he will create a new branch with some name, future 1, future 2, future 3, or sprint 1, sprint 2, sprint 3, or something with the IDs. Then once the code is done, once the code is ready on the branch, whatever branch he created, the branch will be merged to the first level of branch called develop branch. When the moment the code is merged to the develop branch, now our process is going to trigger automatically your CI/CD. So now the CI/CD is nothing but it will take the code from the develop branch. Now the develop branch is nothing but the changes, future branch changes. Now they will build the code, then finally we'll deploy the code from the develop to development environment. Like that. So now here the developers, this environment is for the developers. Now they are going to validate their code on the development environment. Now whatever the changes the guy is implemented, now he is going to validate here. Now he thinks the code looks good, the code working fine. Then what he will do is he will deploy the code from the develop to the QA, quality assurance. So now we are not going to deploy the development branch code into here. Why? Why means there are multiple developers are going to work on the project. So every developer, finally they will merge the code into the develop branch. Now the other guy is working on the future 2 branch. Once his code is ready, then what he will do, he is going to validate his code. So now here the developer 1 is created a future 1 branch, and here the developer 2, now he is working on the future 2 branch. This is the developer 2. So now what he will do, again, once his changes are done, he want to validate his code. Then what he will do, again, he is going to push the code into the develop branch to see the changes. So now if I try to deploy the development changes into my next level of QA environment, I am going to deploy the future 2 also. That is not the correct one, right? Because the future 2 is not validated here on the development environment. So means there is a chance of failures. The code has a bugs. So now if you deploy the code, the bug code into the QA environment, there is the QA people will simply raise a bugs. This is not the proper one. This is not the proper one, right? Again, he has to give a clarification. That is the reason branches, right? So now we are not going to deploy the same branch code into multiple environments. Otherwise, we are going to see this kind of issues. So now what we'll do, what the developers will do, once they will validate their code in the development environment, if they think this is good, then they will move the code into the next branch, next level of branch. So this branch we are going to call as a release branch. So now here this code, now here they will merge the code from the develop to release. Right, first future 1 go to the develop branch. Now the develop branch code will be deployed in the development environment. Code will be validated. If the code looks good, then they will merge the branch develop to release. Now our process, our DevOps process will trigger on the release branch. Now we'll build the code from the release branch, then we'll deploy the code from the release branch to QA environment. Now this environment is given to the testers. Now they will validate, they will write the test cases, they will trigger the test cases, they are going to validate the code. Now once the testers feels it is good, then they are going to give the sign off. So now here, suppose if it is UAT means the client side also they are going to test our code, user acceptance testing. So means client also gives us the approval so that we can deploy the code. So now here, now the release branch code, now the projects are going to maintain a different strategy here. So because the release branch code will be the latest code without any issues. So means I can deploy the same release branch code into the UAT also. Or in our branching strategy, like in our projects, we are going to maintain a separate branch for the UAT deployment. So with the names calls up here, staging. So now here, once the QA is given the sign off, now the release branch code is going to merge to the staging branch. Now again, our process, same process, take the code, build it, and deploy the code into the UAT. Now the client side testing is going to happen. The clients gives the approval sign off, then our code finally will be merged to the last branch called master. So now here they are going to merge from the staging to master, then finally it will be deployed to the production environment. At any stage, if the validation fail, it will go back to the developers. Right, so now, due to that reason, due to the checks, we are going to maintain the branches. So to make sure the proper code is moving to the production.
Shankar, I got a doubt
so
here.
Maze, yes.
Hi. So you said it's a master branch to production environment, right? So is it the master branch from the repository, or we created a new branch called master?
No, the default branch, right? So here, whatever the branch is created, right, that is the master only. We are not going to create a separate branch.
Okay. So we're going to put the code back to master.
Yes. So by default, the master branch will be created once you've done the commits. But here, what are the branches I am discussing here, developer, we are going to create these branches.
Okay.
All the branches.
Okay.
So that I will let you know. So yeah, this is our job only. Right. So here, if you guys observe, for a single repository, for one repository, at least we are going to have these branches minimum to maintain the proper CI/CD. We are going to have develop branch, release branch, staging branch, and master branch. One more branch we are going to have called hotfix branch. So this is a branch, a separate branch we are going to maintain. So we are going to call this as a hotfixes. So why the hotfixes are going to maintain, right? So you have validated on the development, it looks good. Validated on the QA, it looks good. Validated on the staging, it looks good. When deployed the production, failed. The code got failed. Yes, there are multiple chances are there to fail, code failure at the development, at the production environment. So now here we are not going to have the enough time to fix it and validate across all the environments again from the develop to QA, QA, because we are going to have the production window. The deployment will be having a window like 2 hours or 4 hours based on the deployment. So during the span, you have to deploy the code. That's it. Then it is going to freeze out. After the time, like once the 4 hours are completed, then they are not going to allow you to deploy anything under the production environment. So now during the window, you have to deploy the changes. What are the changes are caused to fail at the production? So now if I start testing from the development, 4 hours are not sufficient because there are approvals process will be there to move the next environment. You have to have the approval process. The approval process has to given, then someone has to give the approval, then only you have to go. Now 4 hours, in the span of 4 hours, you cannot validate across all the environments. So that is the reason. What we are going to do here is if something failed at the production level, immediately the code will be taken from the master to hotfix, then fix it, then push back to master straight away. So those are the hot fixes we are going to call as. So hot, say right. So now in a branching strategy, now people ask, what is the branching strategy you guys are following? You guys need to tell these branches: develop, release, staging, or now how the code is going to move. We have to explain this process actually. Right. So once the future branches are ready, then they will merge the code into the develop branch. Then the develop branch code will be deployed into the development environment. Now the development people, the developers are going to validate their code on the development environment. If they feel the code looks good, then they will merge the code from the develop branch to release branch. Now the release branch code will be built and deployed to the QA environment. On the QA environment, testing is going to happen. Once once the QA environment given is the sign up, then the release branch code will be merged to the staging. Now the code will be deployed to the environment from the staging branch. Then the client side, the UAT validation is going to happen on the UAT environment. The UAT environment looks good. Once we got the sign up from the client side, then the staging branch finally will be merged to the master branch. The master branch will be deployed to the production environment. If any issues during the deployment process, so the issues will be fixed on the hotfix branch. From the hotfix branch, it will go to the master and it will go to the production again. So this is the branching strategy which we are following right in our project. Right. So like whatever the repositories we are having in our version control tool. Right. Right now I have 104 repositories. But each repository will be having this branching strategy. These many branches. Right. So now here, who will create these branches? Develop, release, staging, hotfixes, master. We are the guys. Right. Right. The DevOps folks are going to create these branches. Right. So now here, once the project is assigned to us, like once we enter in the project, if it is a scratch, then as part of the architecture, we are going to get the information like, so these are the modules people are going to work for. These modules we require these many repositories. Right. So suppose, so this is my, so I'm switching into my account, my project. Right. So here you can see this is my project, a kind of loyalty program project. So now here you can find here there are n number of repositories. So now here this application is having different modules. They want to have a microservice based application. Earlier it was a monolithic application. Now they want to convert into microservice. So for each service, we have a separate repositories for each service. Likewise. So likewise, you are going to have different repository for each service. Each repository will be having the same branching strategy, like the branches. Suppose if I take one of the repository, it is members. So in the here you can see here I have the master branch, I have the develop branch, and we are going to have the release branch. Right now we are not maintaining staging branch. Is up to us, up to the project level. If they want to deploy the code to the other environments from the release branch, yes, we can do that. Or you want to maintain the proper code, then we will be having a staging branch in between the master and the release. Right. So like that, for each and every repository, we are going to have the branches. Now, who is going to create these branches? DevOps folks. We are right. Once we got the project, now we'll get the list of the services, like the modules. Likewise, so right now here the members is one of the service. Likewise, you are going to get the services list. So now for each service, we are going to create a repository. Now for each repository, no code will be there. Simply are going to create a empty repository On the empty repository, you're going to create the branches, empty branches like master, develop, release, and the other staging branch. Now this repository will be given to the developers. Now what the developers will do? Now they will start developing the code. They will take the code, the empty repository, they will take it into their local. Now they will create their own branches called future one, future two, like that. Now on the future one, they will develop the code, then they will merge the code into the repositories. Sorry, I mean to say branches. Now when the moment they merge the code into branches, now your process is going to trigger. Our process is going to trigger. Right. So now let's go and see how to create these branches and how these branches are going to merge one and each other. Like as I said, the development code will merge to release branch code will merge to staging branch, future branches are going to merge to develop branch, like the merging the code between the branches. Now during the merging, we are going to see the merge conflicts, the issues, right, how to resolve those issues. Right. So once the branches are merged, then you don't require those branches. We can delete the branches, right? If I see here, if you guys observe here, if I go to the my one of the member repository, you can see 256 branches are there. Usually we should have only 1, 2, 3, 4, 5 branches, but here I can see 250 means whatever the branches are pushed by the developers like this, those are not deleted. Like future one, future two will be pushed to your GitHub. Those will be listed on the GitHub side also. So those branches are not deleted here right now. Means we are going to clean up at some point of time, right? So right, likewise. So now here, so once like the merging, the pushing of the branch, then facing the conflicts, then deleting the branches, right? How we are going to manage, and also as part of the DevOps process, applying the rules, protection rules. You need to protect your branches. Otherwise, in the team, anyone can push their code to the branch. If something without knowing us, if someone has pushed their code which is having many bugs, so what will happen? Your Yeah, hello guys. System suddenly hanged out. So yeah, sorry for that. Able to hear me?
Yes,
Yes,
Shankar.
sir.
It's important.
Oh, fine. Yeah. Okay. So now, I think everything is closed out. I think it is gone. Okay, fine. So right, so you guys understand, right? So what is the branching and what is the branching strategy? Let's try to go and see how to create these branches. And as a discussing, like I think we lost the last conversation. Like we are going to apply the rules also as a DevOps guys. Our job is to, if it is a scratch project, and our job is to create the repositories, create the branches for the each and every repository, then apply the protection rules. Then we are going to hand out this repository to the developers. The rules are nothing but no one is directly push their changes, push their own branches to the our repository branches called develop, release, or staging, or master. No straight away merging. So we are going to place a check, like first the code has to be reviewed. So whatever the changes, whatever the code they want to merge to the our repository branches called develop branch or release branch or QA something, the code has to be reviewed by someone. Once the reviewer given the approval, then only the code can be merged into the branch. Then and also we are going to give authorization to the only the leads, not to the developers, so that if something messed up on our strategy, on our branches, we are going to point to the lead. So the lead has to give an explanation for why the code merged into or push it to the other branch without review. So like that. So like that, only authorized persons can merge the code, and also the before the merging the code into the branches, it has to be reviewed by the reviewer. Okay. So now we'll see how to set up this branching rules and how to create the branches and how we are going to manage the branches on your local and the remote. Right. So let's try to connect our, like I lost the Git connectivity also. So let me connect it again. So now Git branch master. So by default, when the repository is created, once any commit on the repositories happen, automatically a master branch will be created as a default. Right. So now in our project, we are going to treat the master branch as a production branch, stable branch. Right. So right. So now here, as part of the branching strategy, we required the first level branch called develop branch. So now here, I would like to create the develop branch. Okay. So now here creating the branches. So creating the branches on the local machine, on the remote side. Right. So local is always for you only, not for everyone. So whatever the changes, whatever the branches, whatever the repositories I am going to create in my local, that is to me only, not for everyone. Unless you push the changes to the remote, nothing but the GitHub. Once the changes are pushed to the GitHub, that is for everyone. Right. So now here the branches again. If you create the branch local means that is to you only, not for everyone. So now creating a branch on the local and creating a branch on the GitHub side. Right. So now here, if I want to create a branch on my local, nothing but my workstation, git branch. Git branch is the command is going to display you the list of branches which are already exist. Okay. So now git branch name. So I'm going to create a branch called develop. Right. So now here a develop branch is going to create. Now inside the develop branch, what kind of content will be there? What is the data will be there in the develop branch? Or is it an empty branch? So when I give the git branch developments, I'm going to tell my git to create a new branch called develop branch. So now what the git is going to do? It is going to create an empty branch, or it's going to place some content inside the develop branch. Right here the thing which we need to focus here is, whenever you are going to create a new branch, for the new branch you need to tell the source branch, because the branch is nothing but a replica of some other branch, a copy. A branch is nothing but a copy of some other branch. Now here you need to tell, whenever you are going to create a new branch, the new branch should be a replica of some X branch. You need to tell the X branch first, means you need to tell the source, then you need to create a new branch on the source. So now the source replica will be a new branch. So how we are going to tell, take this branch as a source, right? So now here, as of now we have only one branch called master. So now when the moment I'm going to create a develop branch, now it's going to take the master as a source. Now for the master is going to create a replica with the name called develop branch. So means whatever the data, whatever the commits, mean the history, whatever is there in the master branch, everything will be replicated into the develop branch. What is the confirmation here? The confirmation is nothing but this star symbol. So star is going to tell you on which branch you are in. Right? If there are n number of branches, now on which branch you are working, that will be let us know by star. The star is going to tell you which branch you are. So now here I am in the master branch. I am on the master branch. So now when I'm going to create a new branch, so the developer branch will be taken as the source of master, because I am in the master branch. Likewise. So tomorrow I am going to create, like, okay, I will show you the example also. Right. So now here the develop branch is nothing but develop branch is the replica of master branch. Right. So now how we are going to confirm? How we are going to confirm that develop is a replica of master branch? There again, the diff command. As I said, the diff are going to use in multiple areas. This is one of the area. So comparing the branches. The comparing the branches also can be done with the diff command. Right. So now here git branch. Now you can see there are two branches. One is develop and second one is master. Now out of the two branches, now where you are, on which branch you are in? I am in the master branch. The star. The star will tell you on which branch you are in. Right. So now I want to confirm whether both are in sync or not. So now what I will do, git diff and the branch names, master against develop. Nothing is displayed, means both are in sync. Right. So now here, now treat as a master is a production code and development is my new branch I have created. Okay. Right. So now in the branching strategy, now I got the new branch called develop branch. So the first level branch. Now it has to be, now this is local again, right? So whatever the changes you are doing on your workstation, that will be local to you only, not for the remote. Now this branch has to be pushed to the GitHub so that the developers are going to use the develop branch. Otherwise, only the master will be there on the master remote side. So now here we need to push this develop branch to the remote. Okay. So now how we are going to push? Git push. To push, git push is the up command. Right. So now here, if I give git push again, right, you have to remember git push always trying to connect to the defaults, default remote path and default branch called master. Default branch called master. Right. So now here I would like to push to the develop branch, not the master. Already master is there in the remote. I have to push the develop so that people can use, the team can use the develop branch. So from there I am going to use full syntax. The full syntax is nothing but git push origin, then the branch name. The branch name should be develop. Enter. Since we are using the SSH mechanism, it is not going to ask any username and password. Straight away, the changes are pushed as a new branch, right? Because at that moment, I don't have the develop branch on the remote, right? So now here, when I push the change, a new branch is created automatically. So let me go to my repository, my account. Go to the repository DevOps repo. Now click on here. We can see master and develop. Right. So if I click on the develop, the same files, 6 commits, develop branch. If I switch to the master, switching the branch means simply selecting the branch. Select the branch. Now I switch to the master, same files, 6 commits. Same. The develop is a replica of master. Now the developers are going to create their own branches like future branches, sprint branches. Now the new branches will be merged to develop, not to the master. Right. So now this is the way to create a branch locally and push the branch to the GitHub side. Creation of branch in the local. Right. Now I want to create a branch not from the local, from the remote side, nothing but from the GitHub side. I would like to create a new branch on the GitHub directly, not into the local and push it to remote. Right. So if you want to create a new branch from the GitHub side, right, so simply click on here. Now you can see a find or create a branch. Cursor will be placed here. Right. So now then the branch which I'm going to create is release branch. I want to create a release branch. So right. So now here, as I said, you have to choose the source. Right. So the new branch is a replica of some X branch. Right. So now your X branch can be a master branch or your X branch can be develop branch. So now what is the source for the release branch? You have to choose the source first, then create the branch. So now anyway, both are in sync. Both my master and develop will be having the same code. I can choose any one. Right. So now suppose I want to create the branch release from the develop branch. So what I will do, first you need to choose the source. Select it. Now I switch it to develop branch. Now create the branch called release, so that the release will be the replica of develop branch. So now here give the branch name release. Now you can see here create a branch release from the develop. Develop is the source. Okay, fine. Click on here. Simple. Now I have 3 branches: master, develop, release. All will be in sync. Right. So here now in my local, I have only 2 branches, not the release, because release is just now created on the GitHub side. It is not yet pulled into your local. Right. So now to make sync, to make sure both are in sync, means just pull it out so that both will be in sync. So now here git pull. Now you can see a release branch, a new branch is pulled out. This is the remote one. So now here git branch, still you are not going to see, but here clearly it is saying a new branch is pulled out, but you are not going to see, right? So when the moment you pull the code, pull the new branches into your local, it is not going to visible. It is not going to display the release branch, the release of some XYZ branch straight away. First time you need to switch to the branch. Later on it will be there. Right? You got the branch, but it is not going to display. It is not going to be visible. Right? So to see the branch in the list, you have to switch to the branch first time. Right? Switching the branch means moving the branch. Now your cursor has to go to the branch. Right? So here on the remote side, switching the branch is very easy. So select the drop down list and select the branch. That's it. You will be switched to the other branch. develop branch. Now on the local, if you want to switch the branch, right? If you want to switch a directory, cd is the command, change directory, then the directory name. Likewise here, if you want to switch one branch to another branch, in the git checkout is the command. Git checkout is the command to switch the branches, right? Suppose I want to switch from the master to develop. So now what I will do, git checkout develop, switch to branch develop. So git branch, you can see now the star, the symbol is showing a develop branch confirmation. Now git checkout my new branch release, switch to new branch release. Now I can see the branch in my list. Once you switch to the branch, we are going to see the branch in the list. The branch is pulled out, but it is not going to be visible first time. So when you have to switch to the branch, so that it will be listed here. You don't require to switch always. One time switch is required, then later on it will be displayed on the list. Right? I am on the release branch. Right. So now here, this is the process of creating a branches and switching the branches, one branch to another branch. On the local, git checkout is the command, and on the remote side, simply just select the branch. Go to the drop down list, select the branch, switching the branch. Right. So now here, my branches are ready. My branching strategy is ready. Now the process is when the moment developers are receive the requirement, they are not going to work straight away on these branches. We are not going to give any kind of access to work on the branches straight away. They have to have created a new branch. On the new branch only they have to do the code changes. Those we are going to call as a future branches. So now what the developers will do, once they will clone the code, they will get the code from the remote to local, then they are going to create a new branch on top of the source called master. Master is having the stable code. Right. So now here git checkout. So I'm going to switch to the master, git branch. Now I'm the master. Right. So now here what I'm going to do, I'm going to create a new branch. As a developer, now I'm going to create a new branch. So now git branch name is the command to create a new branch. We have seen this command. Right. So now here, once the branch is created, then they has to work on the new branch. Means they have to switch the branch. Otherwise, you will be in the same master branch only. Correct. So now here, what they need to do, first they have to create a new branch, then they have to switch to that branch, then start doing the changes. That means, so git branch name is one command, then git checkout branch name is another command. Create and switch, two commands we have to run. So now there is a shortcut. We are having with a single start, with a single command, you can create a branch and you can switch to the branch. We don't require to run two commands. So the shortcut is now, right? So now here git checkout -b is the command. So checkout is for to switch to the branch, -b is for to create a new branch. So what is the branch you are going to create? I want to create a branch called future one. Some name. Enter. Now see here, created a new branch and switch it to the future one. So now git branch. You can see I am in the future one. Like so, it's kind of shortcuts to create a branch and switch. Right. So now once my branch future one is ready, then I'm going to start working on the branch. Okay. So now here ls, so touch login.java. So suppose login mechanism I'm going to start. So now here I can see login.java is created via login.java main. System.out.println and some message I have. Suppose this is some code I have written. Right. So now here, once my changes are done, process will remain same. The process always will remain same, nothing but code changes are done. After that, add the content. Okay, I think modify. We have modified the daily backup also, so that is the reason it's going to ask us add this modified and also login. Okay, so once the changes are done, right, you have to add your files, then save, then push. So now here what I'm going to git add. Now git status. Right, both the files are added here. Now the next one is git commit -m login added. Some message. Right, enter git status work is clean. On the local, now we are clean. Now means now you can push your changes to remote. Right. So now here the process again. So right. So now the developer is created a new branch. On the new branch, he has done the changes as per the requirement. Then you want to push the changes to the GitHub so that the code can be validated on the environments. Right. So now here the process, as part of the process, the code out of the branch he is created straight away is not going to merge into the develop branch. We are going to place the rules, the protection rules. Okay, so let's go to the protection rules first, then we'll see the merging. Okay, so here this is our duty, DevOps duty, applying the rules. Right, so now here we are having 3 branches total. If I click on the branches, we can see master, release, and develop. 3 branches are there. So now I'm going to apply the rules, the protection rules. So to apply the rules, you can see there is an option called settings. This settings visible only to the admins, not for the developers. We are not going to give this access to everyone. So now click on the settings. Here you can see in the left pane there is an option called branches. So now click on the branches. You can see here branch protection rules. Right. So now when we create a branch, when you create a repository, the default branch always will be the master. Right. You can see here the default branch master. Right. So when I'm going to clone the code, or pull the code, it's going to connect to the master because that is the default. Right. So now here I want to change the default branch from master to some other branch. I don't want to make the master as a default. Right. So what I can do here, I can select the branch. Suppose I want to make the developer as a default. Update. So now here your master branch will be replaced with the developer branch as a default branch. So now whoever trying to clone the code from the GitHub, now they will connect to the default branch develop, not to the master. So likewise, we can change the default branches also from the master to some other branch. So now here I am going to add a rule. The rule is nothing but whatever the code, whatever the branch you want to merge to the develop branch, the code has to be reviewed first. Then only it has to go for the merging. So for that, click on add rule. Now in the add rule option, you can see on which branch you want to apply this rule. So that branch name you need to provide here. So I want to apply the rule on the develop branch. Then here you can see there is a option require pull request reviews before the merging. So select it. Now you can place the reviews, like 1 review is required, 2 review, 3 review, like how many reviews you want to apply on the particular code. Like you can select the options. By default, 1 review is enough for me. So then here you can see here there are different options, right? Usually we are going to select the option called reviews required, then a merge option. So here this is the free tier account. So now free one which we are using. So there we are not going to have the merge option, nothing but the giving a permission, giving a authorization to the people who can merge the code. Right. So let me show you in my project. So here I have selected the review here. So then simply click on create. Okay, so let me show you in my account. So sign out. So if I take any repository like members or anything, redemptions, these are all of our services. So I have taken the repository called redemptions. So settings, since I am an admin, so I have the access of settings. So now here you can see branches. You can see we have applied the rules on these branches. Suppose if I take the release branch as an example, edit. Minimum one review is required. Then if I scroll down here, you can see an option called restrict who can push to matching branches. The matching means whatever the branch I have selected here, release branch. Right. So giving a permission to the people. So now here we have selected these peoples. So mean only these guys can merge the code to the release branch, not by others. So this is the option. So here is going to, we need to select the person here. That's it, right? So this is the option. Now here with include the administrator, like there are the extra options. Basically we are going to set up two options. One is reviews required and second one is only the authorized person, like this person can merge the code. So this is an option for even though admins also cannot merge their code. That is the option here actually. Even the admins also cannot merge the code. Right. So now this is the rule we are going to apply on every branch in our strategy, like develop branch, release branch, master branch, and staging branch. On every branch, we are going to apply the rules, the production rules. So now in the develop branch, on the develop branch, we are going to give the authorization to merge the code only to the leads, development leads. The next level of branches like release branch, QA branch, like our staging branch or master branch, we are not going to give, even though developers also, like the leads also, we are going to give to the managers. Now the managers are the responsible person, like technical leads. The next level people are the responsible person to merge the code into the respective branches to make sure it is not going to mess up the branches. Right. So they are the responsible persons like that. Right. So now here, let me go back to my account. Right. So now here I have the develop branch. Then in my local, I have the future one branch. Now I want to merge the code into the develop branch, right? So here I am going to place the rule, protection rules, settings and branches, add a rule, review is mandatory. Review, select the review. Here I don't have the option to merge the code, create. So here you need to provide the branch, which branch, right? So develop branch. I'm going to protect my develop branch. So develop branch and give the select the review option, then create. Right. So now here if I go to the branches again, you can see here one rule is created for the develop branch. If you want to delete, you can delete. If you want to modify, you can modify by clicking the edit button. Right. So likewise for every branch, you are going to add this rule. Like again, click on add rule and select the branch. Select the branch release, then save and create. Like that, we are going to apply the rules for each and every branch of the repository. Right. So now let's go to the local. So now the people, the developers are going to push their changes. Now their changes are in the future branches. So now what they will do, they will push the branch to the remote. So git push origin, then the branch name called future one. Enter. Right now here on the remote side, as of now, the future one is not exist. So that is the reason you can see a new branch is created on the remote side. So now here, let's go to your repository. And you can see here in the list, the future one. Right, the future one is the branch the developer is created. Now he wants to merge his changes into the development so that your process is going to trigger. You can validate the changes on the development environment. Right. So now here, merging the code on the local side, on the remote side. Right. So guys, always remember local means only for you. Even if you've done the merging, if you've done the deletion, everything, it won't reflect on the remote unless you push it. Right. So now to the team, you have to do the changes on the remote side only, so that always the latest changes can take the people. Right. So now here my change has to go to the develop branch. So now here to go to the develop branch, the thing is your code has to be merged into the develop branch. So on the GitHub side, on the remote side, merging the branches. On the remote side, merging the branches will be, we are going to call as a pull requests, PRs. So now we are going to create a pull request, nothing but we are going to create a PR to merge your branch to the destination branch, or merging a one branch to another branch. So straight away we are not going to merge anything here on the GitHub side. We have to create a pull request. Right. So here you can see a button can be seen here, compare and pull request. This button will be visible whenever you push a branch, whenever you push a new branch that is not exist on the remote side, then only you are going to see a button like this. Again, I'm going to push a change to the future one. By that time, you are not going to see, because already the future one is exist. When the new branch is pushing into the remote, by that time you are going to see the compare and pull request. Right. So now here, creating a pull request can be like multiple ways. One is simply click on this button, or you can see here there is a button called new pull request. Okay, multiple ways. Either with this option you can create the pull request, or straight away with this option you can create the pull request. Why the PR are going to create? The PR purpose is to merging your new branch to the destination, or merging the source branch to the destination, or merging two branches, anything like merging. For the merging, we are going to create the pull request. That is only on the GitHub side, not on your local. So select the compare and pull request. Now we can see, we can compare the changes future one to the develop. Right. This is my destination and this is my source. You can see here it is going to tell you whether it is allowing to merge the changes or not. Yes, able to merge, it is allowing us. If I scroll down here, you can see what are the changes you have done on your future branch. Right. So now I have done some changes on the daily backup file by adding this line, and I have created a new file, login.java, and this is the code I have. Completely green means completely new. You can see only the green for the new line 3, like that is going to show you. Right. So now these are the existing data, and on the data you have added new line, one line. Here this is a completely new file. Right. So now here I have done two changes as part of the requirement, and the two changes are present in my future one branch. Now these changes I want to validate. To validate the changes, I require to merge my changes into the develop branch. So that is the reason I am going to create a pull request. Right. So now here you can see there is an option called reviewers. Right. Because without reviewer code, we are not going to allow anyone to merge the code. So now here the reviewers, click on the reviewers, then here we need to select the person, like the leads. Now the developers are going to select their leads to review their code. Right. So now once the reviewer is assigned here, then click on create pull request. Now here you can see the pull request is created. You can see here review is required, merging is blocked. You cannot merge the code until unless the review is completed. So how it came is the protection rules. When I created a rule, when I applied the rule, with the rule, it is not going to allow anyone to merge the code until unless it has been reviewed. Right. So basically this button will be disabled. But here I can see it is enabled because I am an admin here. As an admin, you can merge the pull request even though it is not reviewed. Right. So now here we are not going to take any chance to merge anyone code. For safer side, we are going to keep the access, but always the code has to be reviewed by the developers leads and they have to merge the code. So now they will not see the button is enabled until unless the review is approved. Right. So now here what they will do, once the reviewer assigned here, the person is assigned here, they will get an email. Like this is the pull request is created. This is the pull request number 1. So please review the like he asking for the review. Then what he will do, he will start reviewing the code. File changes, right? So he will click on the file changes, then he will see whatever the files are changed here. Now we'll be having the requirement document. Based on the requirement document, he will review the code. Then he will, if it is good, then he will click on the review changes. Then here he is going to approve. Right. So because the reviewer is not assigned here, because we don't have any other users, that is the reason I am not able to move this option. But usually what the reviewer is going to do, if it is good, then he will click on this approve and he will give a message like comment approved or something. Code looks good, approved. So then he will click here, then he will submit the review. Now if you see some issues like the code is not proper, then he will request for changes. He is not going to approve. Simply he will click on this request for changes, then he will submit it so that the PI will not be merged. It will go to the developer again. It will go back to the developer. Then he has based on the suggestions, he has to work on the fix. Then he has to again push the code back. Like that, the review is going to happen. Right. So once the reviewer is reviewed, then once he given the approval, then here he will go to the conversation and he will go here and he will click on the merge pull request. Here they will see the green color. It will be in green color. Once he given the approval, it will become as a green. Then you can see here the merge pull request. So now finally what he will do, he is going to merge it. So now here I am going to use my privileges, admin privileges, to merge the code. Select. So now here if you want to, like, for the merging, you can give some message, the commit message for this merge. So login is fine. This is good for me. Then what I will do, I'm going to confirm the merging. So now here what is going to merge? Future one is going to merge to the develop branch. The future one code is going to develop branch. Means at present on the develop branch, we are not having the new file called login.java and also a new line in the readme file. Now this file and the new line will be merged to the develop branch from the future one to develop. Right? So here let me merge, confirm merge. So now here you can see pull request successful merged and closed. PR is closed now. So now here once the code is merged, now we don't require this future one because the future one code is already moved to the develop branch. Now unnecessarily maintaining a branch we don't require, means you can delete the branch. Otherwise what will happen, the branch will be there on the GitHub also. In the GitHub the future one will be there even though we are not going to use. But always the best practice will be once the guy merges the code, he is going to delete the branch because this code, the new code already merged to develop branch. Right. So now let me go to the repository, DevOps repo. Now here I can see my develop branch. Right now I'm in the develop branch. It is a default because I changed from the master to default. So develop the default branch. So that is the reason you can see the default is appearing on the develop branch. So now here if I see, I can see the login.java in my develop branch. And also if I go to the readme file, we can see the new line also. Readme file, whatever the file we have added. Daily backup, sorry, daily backup data search. If I go to the daily backup, there I can see CP, the new line also. Right. So now here we have the future one branch, the same code, and my master develop branch also will be having the same code. Means I have merged my code of the future one to develop branch. If you want to confirm, both are in sync or not, what I can do from the GitHub side, if you want to confirm both are in sync or not, what we can do here is, let me go and click on new pull request. So now here you can see compare changes. Now here I'm going to choose the future one. So now here you can see I am trying to compare the future one to develop branch. If anything is there, the discrepancy, it is going to display here. No changes means nothing will. There is nothing means both are in sync. Both the branch. This is the way. In this way, we can confirm whether the two branches are in sync or not on the GitHub side. On the GitHub side, remote side. Right, guys. So this is the process which we need to follow to maintain the code from the local to the remote with the help of PRs. So now the process will be, so now usually they will ask, sometimes people will ask, once we got the requirement, what are the steps we are going to follow? So now my first step will always be clone or fetch or pull. Take the code from the remote to your local, then create the branch, create your future branch, then do the changes on the future branch, then fourth add, fifth commit, then sixth push the new branch, what are the new branch is created, to GitHub. So this is the area for the, sorry, not now here, 6. Then once you push the branch in the GitHub, then create the PR, pull request, and assign to the reviewer. So now this is the part for the developers, whoever wants to merge their code into the higher level environments like develop branch, review branch, developers part. Now the 8th step will be review the code. Who is going to review? The reviewer, who is going to assign. Then 9th, merge the PR. Then the 10th step will be delete the branch. The branch is nothing but the new branch. This is the job of reviewer. So this is the process we are going to follow. Usually once we got the requirement, this is the process. Even if the developers are DevOps, we need to follow the same process. Right. Still, one more step is there in the process. It is not yet completely done. Still, one more step is there in the process. We'll discuss once that area will go to that. Okay. So, but usually, yes, we are not going to do any changes straight away on the branches. Always, it should be on your new branch. Then with the PR only, it has to be merged. Right. So now we have seen creating a branch on the remote and merging the branches on the remote side. So now here I will show you creating a branch on local. I think we have seen, and merging the branch on local. Right. So now how to merge the branch in your workstation, not on the remote side. On the remote side, now we know with the PR. Pull request is the one which is going to allow us to merge the branches on the GitHub side. Right. So now here I will go to my local. Local means my workstation Git branch. Right. So now here I want to merge this future one to develop branch. Right. So this process we have done on the remote side, not on the local. Right. We know no synchronization between the local. Yeah. So now we have seen, right, we have done this practice, this exercise on the remote side, merging the branches. Now the same exercise we are trying to do on the local, right? We know no auto synchronization. Whatever the change I have done, it will not be reflected on my local until unless I pull the code into my local. Right. So now here what I'm going to do, the same exercise I want to do from the local, from my workstation by using the command line CLI. Right. So now we know on the local, if you want to create a branch, git branch is the command and branch name. And to switch the branch, git checkout is the command to switch the branch name. Right. So now here I want to merge the branch by using the CLI. Right. To merge the branch, so now you need to have the source and destination, right? Which branch, right? What is the source branch and what is the destination branch which you want to merge? Now my source will be the feature one branch and my destination will be the develop branch. Right. So let before merging, just review the code. Right. So git difference develop against feature one to the sorry guys. So here we can see I am trying to compare the develop branch and feature one branch. Now I can see here there is a file called daily backup.sh file. Here a new line is added. Correct? That is what we have seen. And I have created a fresh file which is not exist on my develop branch, which is there on the feature one branch login.java with this content. Okay, fine. Okay, it looks good. As part of the requirement, I have done the correct changes. So now I want to merge these changes which I want to develop with the help of CLI on my local. Okay, so now here git. So now to merge the branch on the local from the source to destination, the first step will be you have to be on the destination. Before merging, you need to make sure you are on the destination branch. So now my destination branch will be the develop branch. So means first you have to switch to the develop branch, then go for the merging. So let me see whether I am in the develop branch or not. So now git branch is going to tell you on which branch you are in, right? So now here it is going to show me I am on the future one branch, right? The star symbol is going to tell me on which branch you are in, right? My target will be the destination branch called develop branch. I want to merge my future one to develop means first step will be you have to be on the destination branch means switch to the destination branch, git checkout and develop. Now git branch. First step is completed, nothing but I switch it to the destination branch. Now merge your source branch to the destination. To merge the source branch to the destination branch by using the CLI, git merge is the command. Git merge. Then your source. What is the source here? My source future one. So my source branch will be the future one branch. So now I am in the destination branch. So simply run the command called git merge and your source branch. Enter. That's it. So now your future one is merged to the develop branch. Right. So now git branch. I am in the develop branch. Let's try to open the file cat. Right. Already I can see login.java is added. Now cat daily.backup.sh. I can see the third line. So this is the process to merge a branch on your local site on the workstation, and that is the process. The PR is the process to merge the branch on the remote site. Right. So right guys. So CLI and remote site. So yeah, this is the process to manage the branches on the local and the remote side. Right guys. So today I'm going to stop here. Okay, so I think so much of content we have covered. So still so much of content we are going to see. So on the branches, still some more thing is there, conflicts and other stuff also. Right. So let me know any doubts until now on these topics. What are the topics we have covered?
Shankar, one doubt. So
Yes.
don't we have any pull request concept in the command line interface, like from our local?
Yes. PR is only for the GitHub.
Okay.
No PR. Like, so that is the reason I have explained you this process. To merge the branches, this is the concept.
Okay.
Yeah.
Okay.
But
Like
here,
the
how we can, this is for local, right? So we
correct
don't need to
local.
do all these reviewer concepts and all.
Yeah. So here now, this concept when you are going to use, I will tell you that is in the conflicts. When you are trying to resolve the conflicts, this process we are going to use actually. The merging and other stuff on the local side we are going to use. Otherwise, we don't require this merge in the right. Anyway, we are going to do with the PR survey.
Okay.
Yeah. This anyway, I'm going to repeat this process again because while working on the conflicts, there this command will be the one which we are going to use. So there we'll come to know why we are going to use the merging on the local side. Merging the local, why we are going to use. But anyway, yes, understand the commands, right? So now here, when we are going to use, I will explain you like when we are going to that situation. But you have to remember, you have to understand that if you want to do on the local, what is the process? If you want to do on the remote side, what is the process? The process actually. Yeah. Any doubt? Any other doubt, guys? Are you able to follow or not? Or at least if you give some kind of feedback
Yes.
now, so that I can move forward. I can understand. Okay, you guys are following.
Yes, sir.
Okay.
Yeah, it's fine.
Yeah.
Yeah, it's
Thanks,
better.
guys. Then. Sorry.
It's clear, Shankar. We'll go through this once again, then we'll let you know.
Yeah, sure. Yeah. Please practice it. Practice is very, very important for us. So please practice and let me know if you guys are stuck anywhere or you're facing any issues. So we'll see. Okay. So
Okay.
okay, guys. Then see you on next week
Okay.
on next Saturday. Yeah.
Thank you.
Okay. Thank you.
Thank you all. Yeah. Thank you. Bye bye.